In Transformers, Decepticons come to Earth and stomp across our planet like they own it. But don't worry, in real life it takes a lot of work just to teach a robot not to smash itself into a tree. A look at autonomous robot navigation. Up next on Science Goes to the Movies. Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Lisa Beth Kovetz. The latest Transformer movie flashes back to 1987 when Bumblebee the Autobot, hiding out in a junkyard in a small California beach town, meets Charlie, who quickly figures out that this is no ordinary yellow Volkswagen.
If you see anyone besides me, what do? Great, perfect. Come back now.
Bumblebee and Optimus Prime are sentient, mechanical, self-configuring modular robots, and we are so lucky to have Professor Jizhong Xiao, director of the Robotics Lab at City College, to explain whatever it was that I just said about robots, and to help us separate the possible from the fictional. Welcome, Dr. Xiao.
Thank you for having me on the show.
You work in specifically autonomous navigation and 3D simultaneous localization and mapping. And it just seems very clear to me that you guys up at CCNY Robotics Lab are the people who created the Transformers.
Actually, we're not directly create the Transformer. We're developing some robotics technology which may contribute to the creation of the Transformer.
Go CCNY. If CCNY's robotic lab didn't make Optimus Prime, he's got some of their tech in his head, because when Transformers come to Earth, they see and they navigate easily in all terrains. In real-life robotics, that kind of navigation is problematic. Dr. Xiao's lab is working to create robots that move autonomously in a complicated world, starting with robots that can create a map. Why does a robot need a map?
One of the most fundamental problems every robot must to solve is autonomous navigation. It is a very challenging task for any kind of robots, especially when they navigate in unknown or complicated environments. Right? Take an example, right? For example, how human beings can navigate, can find a conference room in an office building.
We ask everybody else on the way how to get there. We ask the other humans how to get there.
Yes, exactly. So if the human beings are given a map, right, he can first find out some clues like door numbers, and then try to localize where he is against the map, and then try to figure out the path planning to the destination.
Right, I have the door number, and the door number is 5, so 432, I know that I'm on my way. And that's what you're teaching a robot how to do?
Yes, that's exactly a very easy job because you know the map. Think about if you don't have the map, what can you do?
I not only do, if I'm a robot, not only do I not have the map, but I don't understand any of the conventions of human mapping or human organization of office buildings. So they're really starting from zero.
Yes, exactly. So the robots need to first explore, right? So it consists of 2 steps, move and perception, right?
Movement and perception?
Yeah, move, step, motion and perception.
Motion and perception.
And at the same time, they build up a map incrementally in his brain or in his computer.
So once the robot has found his way from the entrance to Grove School of Engineering to your office, the robot can find that again and again and again and again.
Yes.
And share it.
Yes, exactly. So after he incrementally build up the map, right, they can localize where I was, right? And then they have the knowledge of the entire, for example, campus or buildings. Right?
This is because the GPS that we're all so accustomed to is not mapping details, not mapping the vertical details that happen in buildings, right?
Yes. Yeah, actually, GPS is a good tool for outdoor navigation. But inside the building, you don't have the GPS. So you must count on the vision, count on your computer vision to detect some salient features, right? Those features include some signage, door numbers, floor numbers, or for the computer vision, they can detect some corners, edges, right? And then those features give you a clue to localize where am I.
Right. So beyond helping Optimus Prime find his way up into your office, how does this help humans also, this autonomous mapping?
Yes, actually, in robotics, this procedure have a technical term. It's called simultaneous localization and mapping. So we try to apply this technology to help blind people.
Oh.
Yeah. Actually, we have ongoing project. It's called ISANA, Intelligent Situation Awareness and Navigation Aid. We try to use the SNAP technology, implement in a cell phone, and help the blind people to navigate, to achieve independence travel.
So a blind person can have this cell phone talk to them and tell them, turn here, turn there, the same way a GPS does for a car.
Obstacle front. You are approaching door on your front 2 feet.
Yeah, it's very similar to these procedures. First of all, for example, in a office building, right? Building management can have a cell phone. They do the mapping, right? They take that's the first procedure. Do the mapping. They create a 3D map or a 2D map, or they can import a flow map from the CAD model. Yeah.
So your robot walks the building and builds a map for the building?
Yes, yeah. After they build the map for the building, and then we can hand over this software to the blind people. Then blind people can use this smartphone to localize itself. They can use the camera as their own eyes and to locate where am I.
Oh, so they're holding the camera, or they're holding the camera, and they're walking through the building, and the camera knows that it's gotten to the 4th floor or the next left turn that it needs to make.
Yes.
That's amazing.
Yeah, and then the camera, they can have a speaker. They can provide some instructions, turn left, turn right, right? And then our software also have automatic path planning to a destination. They can show where to go.
So automatic past planning.
Yeah, path planning.
Path planning.
Motion planning.
That's a huge tool. That's a huge tool, and also making robots' lives so much easier.
Yes, actually, this robotics technology is a very lightweight and self-content tools. We are inspired by the robotics Google car and some other robotics navigation technology. So we develop assistive navigation aid for the blind people, right? There are 39 million blind people worldwide. They cannot travel independently.
Right.
So that's why we try to explore robotics and computer vision technology to help them to achieve independent travel.
Right, there was a gap. Well, you could get to Washington,
Yeah.
but then what you do once you get to your location, it's a really wonderful new technology.
Yes. The first project have finished, and we make a successful demonstration in the Department of Transportation headquarters building.
Oh, really?
In Washington, D.C.
Oh, that's terrific.
Yeah, we have attracted a lot of blind peoples and stakeholders, and then they witnessed the success of this project.
That's terrific. That's terrific. You know, in the Transformers canon, the origin of the Transformers is very complicated. But in real life, you told me in your office that robots are created to do 4A tasks in 4D environments. What are the 4 A's and D's of robotic creation?
Yes, actually, 4A refers to automation, augmentation, assistive, and autonomous. Yeah, automation, you can imagine, right? We have a lot of robot arms in factory floor to automate the car building process. Augmentation, that means you augment the human capability. Assistive, like assistive navigation aid to help blind people. Autonomous, that means unmanned vehicles, Google cars, right? Those autonomous navigation.
Right.
The 4D task means difficult, dangerous, dirty, and dark.
Those are the things we don't want to do.
Yes,
Yeah.
exactly. Yeah.
I think that those are an important point for a screenwriter, that's what real robots are created for, the 4As and the 4Ds.
Yes.
Batman and Robin climb a Gotham City skyscraper using just a rope. Spider-Man's wall crawl leaves a sticky film on buildings all across New York City. And your lab has created a wall climbing robot. Did you create this robot to clean up after Spider-Man?
Yes, actually, we are inspired by Spider-Man. We are trying to develop wall climbing robots as a tool to clean the curtain wall of a skyscraper, or to do some non-destructive inspection of infrastructures, like building facade, bridge, dams, and tunnels.
So all of those scaffoldings that we see going up all over New York City could be replaced by these wall climbers doing their inspections.
Yeah, that's our aim.
Yeah, and you know, we were joking about Spider-Man, but really cleaning up after Spider-Man is a good example of a 4A task in a 4D environment, right?
Yes, yeah. Yeah, take this cleaning job as an example, right? So current practice of manual cleaning is dangerous and is expensive, and sometimes may put the window washer to a life-threatening situation.
Yeah.
I remember in 2014 in World Trade Center, right?
Yeah.
The suspended scaffolding tilt, and then two window washer, they trapped. NYPD have to break the wall, glass wall from the inside and rescue them.
Right.
So that's a very dangerous situation. So in our lab, we try to develop wall climbing robots and to provide some effective and efficient tools to automate the cleaning process.
Right, right. So there goes Spider-Man swinging across New York City, and then there's Dr. Xiao's robots climbing up after him, cleaning up his mess.
Yeah. Actually, our robot will be tilted down from the top, and then they do the cleaning. And then we don't have to get the people involved.
Right.
They can do it
Right.
automatically.
Spider-Man sticks with sticky stuff. How do your robots stick to the walls?
Actually, it's a kind of combination of suction and aerodynamic attraction.
Oh.
Yeah, actually, simply put, if you have too much suction, right, of course, it's good to stick there, but they cannot move. So we need to have a balance between suction and mobility. So our robot will provide mobility and flexibility, and then have some cleaning tools to help the human workers.
When Hollywood creates a fictional robot, they always get two eyes, mostly because we have two eyes, but also because stereo vision is necessary for depth perception. But Dr. Xiao has created a robotic camera with nearly full circle panoramic vision using a single lens. And if you've ever worked or played with a drone, you might know why that's amazing and useful. But for the rest of us, what's the advantage of one eye acting as two?
So it's called Immunodirectional stereo vision system, which we developed for UAV. We use the mirror to provide 360 degree of field of view. And we have two mirrors. One object can have two images. So one eye, right, the lens can see two images, like we have two eyes, right? So in this case, we can calculate the distance.
So what's really, really initially, of course, very useful for that is the weight.
Yes.
Because one eye weighs less than two eyes.
Yes.
for any kind of drone. So how do you do that? You have one lens and a mirror. Why is it that it's at such a particular angle? Is it the geometry that makes it so remarkable?
Yes, actually,
Oh.
the configuration is this way. We have one mirror, and then another mirror. Here, there is a hole. The lens is looking up, right, to see the mirrors. So the image they can see is the top image, which have the objects to reflect to this image.
Oh.
Yeah.
So it's a complex geometric form.
Yes, it's very complex geometry form. It's folded lens.
It's not just stick up a mirror and now you got two things. It has to.
It's a hyperbolic mirror. Yeah, we have two hyperbolic mirrors, one on top of it.
So it's not just the placement. It's the shapes of the mirrors. It's the location. It's the geometry. It's a big deal.
Yes, exactly. That's the customer designed perception sensors for UAV because we need reduce the weight.
Right.
Yeah, and we try to eliminate synchronization of multiple cameras. And
Right.
also, we need to process the image in onboard computer, right? So everything should be smaller, lightweight,
Right.
and fit into the drones, the small drones.
How did you come up with this idea? This is a lot of moving parts. What was the inspiration?
Yeah, actually, inspiration. Of course, we did a lot of literature review. There are a lot of research in these areas, but to fit our needs, right, we compromise some accuracy with the compatibility.
So you compromised accuracy for size.
Yes.
I mean, this sounds like an amazing thing.
Yeah. Actually, we have a big mirror, which serves as a kind of protection. When we had a competition, it's the raining days. Yeah, other robots cannot work. Our robots have this kind of mirror canopy, right? So we're not affected by raining days.
So you solved two problems at the same time, accidentally.
Yes, actually, eventually, our robots win the design competition, the first place design competition. We beat the Princeton team. Yeah, we're proud of it.
Yeah, of course you are. Of course you are. CCNY beat Princeton. Way to go. But what was your inspiration? What made you think that? What was the need that you wanted to fill?
Actually, for some common design for the robotic navigation, right, especially in those competitions, most of the team use the laser scanner to detect the objects, right? And it's very expensive and costly. And some of the team use the regular stereo vision system, right, like a human eyes.
And that's heavy.
That's heavy, right? And also they have a very narrow field of view. But our system have a 360 degree of view. So that's the most advantage.
So we can see a lot of Cyclops coming out of CCNY.
Yeah, it's a kind of, right? Cyclops, they have advantage. They can see 360 degree.
Yeah.
They can see front and can see back. So it gives them a good sense of environment. They can do the navigation much easier.
Right, because if laser sensors are the standard form, lasers are monodirectional.
Yeah.
Or even if it's in an arc, they're not
Yeah.
backwards and forwards.
Yes, they
So
cannot.
So this was a big breakthrough in robotics.
Yeah, that's kind of innovation.
Yeah.
New things we try to explore. Yeah.
But movies are we're always gonna see robots with two eyes because that makes us more comfortable or more uncomfortable.
Yeah, correct.
In Transformers, all the robots are Autobots, short for autonomous robotic organisms. These robots think and move and make decisions for themselves. Dr. Xiao, Transformers in the movies are kind of scary, but in real life, when we talk about autonomous robots, are we really just kind of talking about like a Roomba? Is that the height of autonomous robots in America right now?
No, a Roomba is a kind of a simple application for household cleaning. Self-driving car is one research direction, which requires navigation skills. And as a robotics researcher, in my opinion, robot is still a machine, right? They are not as smart as human beings. So I'm not afraid of they will take over the world.
You're not. Most of the scientists we talk to are not afraid of those things.
Yes, a long way to go
Yeah.
to build, to develop some artificial intelligence, and to develop some self-learning robots, right? But at the current stage, I didn't see any scary situation will happen. At least that's my own opinion, right?
You don't walk into your lab late at night and hear a creak behind you and think,
No, I'm not afraid of that. Yeah.
You've taught your autonomous drones to fly through the forest and not hit the trees. How do they do that?
Yes, actually, it's very challenging to do the navigation in complicated environment, like a wooded area, right? Like this one, right? So actually, they count on perception, planning, and action, right?
So let me just make sure that I really understand what you have taught these drones to do. They can see a tree that you didn't know was going to be there, and they can avoid it.
Yes.
That's pretty, that's pretty Star Wars up there.
Yes, actually, current technology, we can already can achieve these functionalities, right? We have cameras or lasers. They can detect the surroundings. They know where's the tree, where's the obstacles. And then they plan the path, try to avoid the trees to the destination, and then action, that's the flying. We have a kinematic model, dynamic model, and then how to control the drones to achieve those maneuver. That's achievable.
Wow. Well, so a robot really is only as good as its sensors.
In some sense, the sensor plays a very important role. Without the sensor, they cannot understand the surrounding.
Right.
They cannot plan motion correctly, right?
So the autonomous element of it is really related to sensors.
Yes,
Because they can only make decisions about stuff that they can perceive.
yes, exactly, yeah.
And also, when my Roomba fell down the staircase, it did not commit suicide because the cat kept tormenting it. It fell down the staircase because the sensor failed. I feel so much better.
Yes, you're right. So cat as a real animal is much smarter than the machine, than the robots, right? Definitely, the cat can torture the Roomba by blocking the way, force the Roomba to replan, to avoid the obstacles, and even worse, they can kill the Roomba but switch off the power. Right? Of course, currently, I don't believe the cat is smart enough to locate the switch button, but human beings can do it, right? So we are not afraid of the robot take over the world.
Right, because still in cat versus Roomba, cat's winning.
Yes, exactly. Yeah.
Dr. Xiao, you're a roboticist, but most of your degrees are in computer science and electrical engineering. Are computers the future of robotics?
Yes, actually, robotics is essentially a multidisciplinary research area. We require people from mechanical engineer, electrical engineer, computer science to tackle different problems from different angles, right? For example, mechanical engineer, they need to design the robot structures, right, locomotions. And we also need computer engineer or electrical engineer to design the circuitry, to control the motor, to provide the robots with the motion capability. And also very important, computer science. We need a computer scientist to process the camera image processing and object recognition or learning-based some artificial intelligence to empower the robot with more functionalities so that they can achieve some capability like Transformer, which is envisioned by Hollywood movies.
So let's say a kid is in high school and they're starting to put together their field of study, and they want to be a roboticist. What should they focus on?
Actually, they should explore. They should expand their knowledge, right? I have kids, they're very fascinated by the robots, right? They participate in some first robotics competition. That's a very good opportunity, right? They can do the mechanical design, they can do the simple programming, and then see how the code make the robot moves, inspire them, right? Then we attract them to the engineer, to the science, STEM, science, technology, engineer, and the math, the field. So that's the future of our science and the technology in the USA.
So really, if you want to do robotics, do robotics.
Yeah, that's I always encourage my son to to participate in those robotics projects. They will learn a lot from that.
Dr. Xiao, thank you so much for joining us.
Thank you very much for having me. Yeah.